everyone for being here. My name is Yang Sang. I'm a professor in computer science at UC Berkeley and also a co-director of a campus-wide center called Berkeley Center for Responsible Decentralized Intelligence. So today I'll talk about towards building responsible decentralized AI. So we are all here really excited about the rapid advancements in frontier AI. And we hope that in the not too distant future, we'll be entering this true AI era where we have different types of agents, personal assistants, that actually will intermediate most of the communications with external world, and diverse agents for solving different tasks. And we'll also have these decentralized autonomous agents that will interact and act in decentralized manner. However, as we enter this AI era, there are many different challenges. Given the interest of time in this talk, I'll mainly cover three different main challenge areas. So the first one is on building safe and secure AI. And within this, we'll actually talk about three topics: how we can ensure trustworthy AI, how we can mitigate misuse of AI, and also our recent proposal with a number of leading AI researchers on the path for science and evidence-based AI policy. And I will also talk about the importance of decentralized AI to enable user-controlled open architecture and protocol for innovation instead of platform-controlled solutions. And finally, I'll touch on how we can ensure responsible, fair data use and value attributions instead of platform-centric economy. So first, on building safe and secure AI. As we make rapid advancements in AI, we are really excited about all the great capabilities that AI can bring us. But on the other hand, also there is a broad spectrum of AI risks that we need to be aware of. So recently, led by Yoshua Bengio, a Turing Award winner, I'm also part of this effort, together with over hundreds leading AI researchers globally from over 30 countries. We recently released this international AI safety report listing out and explore a broad spectrum of different types of AI risks. And also, as we deploy machine learning, it's important to consider the presence of attackers for a number of reasons. One, history has shown that attackers always follow the footsteps of new technology development, or sometimes even leases. And also, this time, the stake is even higher. As AI controls more and more systems, attackers will have higher and higher incentives to compromise these systems. And also, as AI becomes more and more capable, the consequence of misuse by attackers will also become more and more severe. And hence, as we deploy AI, we really need to consider the presence of attackers. And given the importance of this area, various governments also have put emphasis in building safe and trustworthy AI. So overall, our goal is to advance safe and secure AI innovation to ensure its potential benefits are responsibly realized and widely shared. So in order to achieve this goal, here I'll talk about three main areas that we need to pay attention to. So the first one is, as I mentioned, how we can ensure trustworthiness of AI. And the second one is how we can mitigate misuse of AI by malicious attackers. And then I'll talk about our recent proposal on the path for science and evidence-based AI policy. So first, as we deploy AI, it's important to ensure trustworthiness of AI. And there are many different perspectives for trustworthiness of AI, including robustness, including adversarial robustness, out-of-distribution robustness, and also other aspects, including privacy, hallucination, fairness, toxicity, and so on. So given the interest of time, we won't have time to go into all these different perspectives. So here I'll just give you, as one example, for the adversarial attacks, adversarial robustness. So my group has been among the earliest to study this problem of adversarial attacks in deep learning. with our work and others' work, we have shown that essentially adversarial attacks is prevalent in all deep learning systems, including different types of model architectures, different application domains, and so on. And we have the rare honor and pleasure to have some of the artifacts of our research has become part of the permanent collection at the Science Museum of London. This is the artifact of real-world physical adversarial examples that can fool, for example, computer vision systems to misclassify the stop sign into speed limit sign and so on, as an example. And when we started working in the space, in the beginning, there were only very few papers being published on this topic each year, but now the field has exploded with thousands of papers published in this area every year. So now in large language models, these issues continue to be prevalent. So this is our recent work on decoding trust, the first comprehensive evaluation framework for trustworthiness of large language models, where we developed new algorithms and the evaluation framework to analyze many different perspectives of trustworthiness of large language models, as I listed earlier. And our work has won the Best Paper Awards at NeurIPS and also the Best Scientific Cybersecurity Paper Awards of year 2024, given by NSA, where each year they only give out one paper award for this. And with our work, we have analyzed different leading large language models and demonstrating that all these different large language models, they can all be very easily attacked and have many different types of risks, again, in all the different perspectives that as I mentioned. And also, so far I've mainly talked about these adversarial attacks at inference time, and we call them adversarial examples. And they also can be done through like prompt engineering, jailbreak, and so on. And these issues also appear at other stages of the machine learning pipeline, including, for example, pre-training and fine-tuning. And in this case, we call them data poisoning. So essentially, attackers can introduce poisoned data, including poisoned data labels, to fool the machine learning system to learn the wrong model. So for example, my group, actually, we were the first to study and propose this issue of data poisoning. And back then, we showed that actually we can also install these backdoors into the machine learning system, such that in this particular case, actually even works in the physical environment, where normally this facial recognition system can recognize a user correctly, but when a user wears a specific type of glasses, it will trick the facial recognition system to misrecognize the user into a targeted user. And again, fast forward to large language models, they also suffer the same type of issues. So this is an example of work from Anthropics illustrating that attackers can embed these backdoors into the large language model. During normal circumstances, the large language model will be can generate just normal code. But however, when specific type of phrases appears, in this case, current year 2024, the model actually will then generate vulnerable code. And these issues persist even after the model has been fine-tuned and so on. And also in our recent work, we have shown that this type of issues also can occur at other stages as well. So for example, we can install backdoor through RAG that fool the agents, to poison agents as well. So these are our examples of different types of adversarial attacks. And in fact, as I shown earlier, the field has exploded with many thousands of papers a year. But however, largely in the community, we have mainly made progress in the adversarial attack side, where we have created many different types of novel attack methods. But however, on the defense side, there has been very little progress being made. And in particular, on the defense side, we have made extremely, very little progress, almost no progress as a whole community. So this poses a huge challenge for AI safety. Essentially, for AI safety, as I mentioned, current AI safety and alignment mechanisms are easily evaded by adversarial attacks. And today, we don't have good solutions to defend against these adversarial attacks. And any effective AI safety mechanism actually need to be resilient against these adversarial attacks. And this poses huge open challenges. So essentially, we need to develop new technologies, new methods to address these type of issues. So just as some examples of some of our recent work in collaboration with other collaborators and so on, we have been exploring different directions how we can address these issues. So one example is this work on representation engineering, where we show that by observing the model activation space during inference time, and also by constructing specific types of what we call constructive inputs, we can then actually train another model. We can actually, from observing the model activation on these constructive inputs, we can actually then identify certain patterns or certain directions, for example, at different layers in the model during for the model in the model activation space. That actually correlates with certain types of behaviors of the model, such as whether the model is honest, whether the model is hallucinating, and so on. We call this representation reading. So essentially, by reading the model activation, we can essentially we can identify certain model behaviors. And more importantly, by using this information, we can also do what we call as representation control, where, for example, by amplifying the model activation along certain directions at certain layers, we can actually change model behaviors, for example, making the model more honest or less honest, and so on. So this provides an important mechanism, an important arsenal for us to provide stronger safety control, such that we can actually, this is one advantage of artificial neural networks versus the human brain, is that we can fully observe the neural networks activation, and then we can actually do real-time modification and control. So this is a promising direction for us to exert further control in the for these model behaviors. And as a step forward in another direction, we together with other leading AI researchers, including Yoshua Bengio and so on, recently we have launched an initiative on quantitative AI safety initiative with the goal of exploring new methods to provide quantitative guarantees for AI safety to help build safer AI. So that's just a quick overview on the first aspect, how we can, the importance and how we can ensure trustworthiness and safety of AI. The second part is also we need to ensure, given that AI technology can be used both by good actors and by bad actors, then how can we mitigate misuse of AI? So in particular, earlier I listed a broad spectrum of different AI risks. But for me personally, I do strongly believe that actually cybersecurity, among this huge broad spectrum of AI risks, cybersecurity is one of the biggest AI risk domains for a number of reasons. Currently, already there are diverse incentives for attacks, and attacks already are causing huge issues, causing hundreds of billions of dollars of financial damage every year. And also, with the recent fast increase in reasoning and coding capabilities, these have direct implications on cybersecurity. And increased AI capabilities can significantly reduce attack costs and increase attack scale. So a key question is, how will frontier AI change the landscape of cybersecurity? In particular, given that AI is a dual-use technology that can help both attackers and defenders, how we can ensure that who will AI help more, attackers versus defenders? So this is what we set out to explore and study recently. So in our recent study, we did a comprehensive and systematic marginal risk assessment in the landscape of cybersecurity to study how frontier AI may impact the landscape of cybersecurity. Given interest of time, I won't be able to go into details, but essentially, so here are some high-level overviews where we studied how frontier AI may impact different stages of attacks and also defenses, illustrating that currently frontier AI is already helping with different attack stages at different levels. But however, on the defense side, actually, frontier AI has not really been very effective in helping on the defender side yet. And also, there's a natural asymmetry between defense and offense. For example, attackers only need to find one attack that works, but defenders need to fix all bugs and prevent all attacks to succeed. And cost for defense is much higher can be much higher than attacks. And deploying defenses, even when, for example, patches are available, it can actually take a long time and require a lot of resources. The defenders need to deploy the fix, need to do a lot of testing, and need to do deployment globally. And a lot of legacy systems still are not patched, and attackers can just learn vulnerability and generate exploits using public information of patches and can exploit systems before they can even be patched. So all this leads to a not very rosy future. In particular, the consequence of misuse AI in attacks is vast. Misuse of frontier AI can completely change the attack landscape. It can help with every attack stage, can apply to every attack domain in the attack landscape, can increase attacker capability, devise new attack methods and strategies, can reduce resources and cost needed for attacks, and can completely change the economic landscape of attacks, and can help automate large-scale attacks and make attacks more evasive and stealthier. So this also, we can borrow from some of the past lessons. So overall, from our analysis, we show that AI can help attackers more, in particular in the near term. Current systems are already highly vulnerable and ill-prepared for AI-assisted attacks. And also, organizations and systems often only spend efforts and resources after seeing attacks and damages. As cost of attacks going down, we expect to see unprecedented increase in attacks, learned from lessons from spam, script kiddies, and so on. And also today, we are already seeing increase in attacks. And also the world was not prepared for a pandemic such as COVID, despite early warning. Attacks assisted with AI can be much worse. So the question is then, what can we do? How can we actually have AI to help more, can help defenders more instead of attackers to tip the balance? So in the past, essentially, if you look at the different types of defenses, so the security community and also my own research over the past decades essentially have gone through paradigm shifts. Earlier, the community has focused on reactive defense, which focuses on detecting attacks when they happen and block these attacks, and also proactive defense through bug finding that actually try to find these vulnerabilities through fuzzing and so on before attackers. However, for these type of defenses, we do believe that actually frontier AI can still help attackers more than defenders. So what we really need to do is we propose that we need to focus more on proactive defense secured by construction. So what do I mean by this? Essentially, in contrast to bug finding and attack detection and reactive defense, we want to actually design and build provably secure programs and systems. So in particular, we can specify certain security properties formally, and then use formal verification to formally prove that the program and system satisfies these desired security properties. In fact, thanks to the efforts from formal verification community, we have entered the era of formally verified systems. And in particular, these are some examples of different types of systems that actually have been formally verified, including microkernels, file systems, and so on. And however, these systems actually have not been widely used. And also there has been many challenges, in particular because actually it has been very labor intensive to do the formal verification for these systems. And oftentimes for each system, we need tens of proof engineers to actually formally do the formal verification. To try to address these issues, my group has been among the earliest to use deep learning to help automate theorem proving. Even back 6-7 years ago, my group, together with other collaborators, including Ilya from OpenAI back then, we have developed technologies to use deep learning to help automate certain steps in theorem proving. However, back then, even though we showed that deep learning is helpful in improving automation in theorem proving, but however, technology was still very early. Now, fast forward, with the recent advancements in large language models and frontier AI technologies, I personally believe that we are hitting an inflection point. So in addition to the recent advancement that we have seen in AI for formal math, for AI for informal math, we believe that now with these frontier AI technologies, we can significantly enhance the capabilities for AI for formal math. So essentially, by using frontier AI technologies, we can, through auto-formalization, we can translate informal math into formal theorem statements and so on, and then build proof assistance to actually automate theorem proving. And in this way, we can use AI to help us to automatically prove theorems and then do program verification. So with this type of technology, so instead of training agents to just play Go, to play games such as Go, we hope that we can train agents to automatically prove theorems and do theorem proving for program verification, and also use this in conjunction with program synthesis. So unlike today, when we generate code using AI, we have no guarantees of the correctness and security of the code. Instead, using this approach, we can do provably secure code generation, where we can generate code and proofs together to provide formal guarantees of the correctness and security of the generated code. And also here's a lesson. Here's some lessons learned from another domain, medical device security. So my group, together with other collaborators, we did the first medical device security analysis in the public literature. And we showed that back then, we can find critical security vulnerabilities in medical devices such as defibrillators and so on. And back then, FDA's approval process for medical device actually has no mention of security at all. So a few years later, following our work and others' work, FDA changed their approval process, issued guidance recommendation on medical device security. So the lesson here is that security space is very complex, and the frontier AI will have a huge impact in cybersecurity. It can, so we're already seeing significant increase in attacks due to GenAI, and in the near term, our analysis shows that AI will help attackers more than defenders. And hence, it's important to learn from the past lessons and act now. So we need to build and deploy plans to improve security posture to help increase the resilience in society against cyber attacks. And also we need to use AI to build secure systems with provable guarantees. So that's the first two parts. And now I will briefly talk about our proposal, recently launched proposal on the path for science and evidence-based AI policy. So as the fast advancement in frontier AI, there's the format got a little messed up. So we are seeing a sudden proliferation of AI builds. So currently there are about 120 AI builds in progress at a federal level, And also at least 45 states have introduced their AI bills, around 600 AI bills. But however, our community is fragmented on AI policy. AI research and policy community lacks a consensus on the evidence base relevant for effective policy making, including what risks should be prioritized for when they will materialize, and who should be responsible for addressing these risks. So addressing these issues recently, together with a number of other leading AI researchers, we have launched a proposal on a path for science and evidence-based AI policy. And you can see more information here. And essentially, we propose that AI policy should be informed by scientific understanding of AI risks and how to successfully mitigate them. And however, our current scientific understanding is quite limited. So we need to prioritize advancing scientific understanding of AI risks and how to best mitigate them, and also to advance science and evidence-based AI policy. And in our proposal, we list out 5 different priorities combining science and policy. And also, these efforts, we have received wide support across industry, academia, and civil society, including other leading AI researchers and also leaders from frontier AI labs and civil societies and academia and so on. And we have volunteers from over 250 institutions have volunteered to contribute as well. So I'm actually running out of time. I only finished the first third of my my planned talk, covering building safe and secure AI. So now, in the remaining few minutes, I'll just briefly talk about the remaining segments. So first is on decentralized AI, building user-controlled open architecture and protocol for innovation instead of platform-controlled. So with the current internet is platform-controlled, users lose control and have very little influence. And essentially, users are the products, and creators are now fairly compensated, and the closed platform can hinder innovation. So essentially, the question is how can we actually build a different solution? Ideally, we want to build an open platform that's user and contributor controlled with decentralized trust. And in particular, our recent proposal actually leverages confidential compute and distributed ledger together to build what we call AI assets. So in particular, so my group and with our collaborators, we have been among the earliest we actually built the first open source secure enclave. And also even back then, many years ago, actually, NVIDIA first visited Berkeley to our group, and we discussed actually we were urging NVIDIA to add secure enclave confidential compute in their GPU. So we are very glad to see that finally, recently, this actually has become a reality, is available actually in the real world. And back then, 6 years ago, we organized the open source secure enclave workshop at Berkeley with many leading companies and academia joining the workshop. And back then, I had a prediction, I had a bet. Back then, in 10 years, most chips will have secure enclave capabilities, and also most computation will happen in a secure enclave. So now we have a few more years to go. I think we are on track for my prediction to be true. So many of the chips today already have the secure enclave capabilities. And using the secure enclave confidential compute capabilities, it can really unleash new capabilities and enable us to build new applications and so on. So this is just a very simple example. When you run these models in secure enclaves, you can have fully privacy-preserving chats instead of others may learn about, for example, chat and so on. But that's just a simple example. With this type of technology in conjunction with digital ledger, with blockchains, we can enable what we call AI assets, where we can create these policy-controlled digital assets where asset plus policy can be combined. And users can specify how they want their asset, either it's data or the models they trained, how they want their assets to be used to specify the policy. And also they can say what kind of rewards they want to get. And the blockchain can help enforce, can help track and enforce the policy, and when the computation is done inside secure enclave, this in conjunction enables what we call policy compliant computing. So again, given the interest of time, I won't have time to go into details. This type of technology can actually really enable, unleash innovation, can help reduce friction and trust needed for collaborative learning and so on. And we have a full architecture for building this open platform for AI assets. Again, given the interest of time, I won't be able to go into the details. And by combining different component technologies that, as I mentioned earlier, we can enable these AI assets that enable user-controlled and open architecture and protocol for innovation instead of platform-controlled. And then finally, I just wanted to briefly mention that we also need to address the value attribution issue to enable responsible, fair data use and the value contribution. So data is the lifeblood of AI, but however, there's been fundamental questions of what's a good way to attribute value to data contributed to, for example, to training models and so on. So my group, we were the first to propose actually a rigorous framework using Shapley value, a concept proposed by Lloyd Shapley, Nobel laureate in economics, to show that what's a rigorous way to actually attribute value to data contributed to training models. And when we put all this together, essentially we hope that we can, instead of today, users are being controlled, we are platform controlled, we hope to build a new an alternative where actually users are under control, and these assistants will actually, instead of operating for maximizing profits for large companies, it will actually maximize user value and works in the best interests of users. So, and with this approach, we hope to enable an open, responsible AI economy that supports transparency, community governance for accelerated innovation, and responsibility with safety, trustworthiness, reliability, and support decentralized AI economy with frictionless, disintermediate, and value attribution based on contribution. So with that, so thanks everyone. So if you are interested in reading our paper draft for the AI risk in cybersecurity, you can scan this QR code, enter your information. We are very happy to share with you our draft. And also, I'm running a MOOC, Massive Open Online course on large language model agents. You can learn more here. Currently, we have over 22,000 enrolled. It's a great way for you to learn more about the frontier AI technologies, in particular in the agent domain. Thank you.
Awesome. Thank you so much, Professor Song.